Hey everyone, welcome back to the channel. Today we are deep diving into Amazon Elastic Block Storage, that is also known as EBS, one of the most fundamental services you will use on AWS. Here is the deal. If you are running an EC2 instance in the production, you need to understand EBS. This is how you process data, create backups, and ensure your application have the storage they need to run reliably. Think of it in this way. Your EC2 instance needs somewhere to store the operating system applications and data. That's where EBS comes in. It's like having an hard drive in the cloud that you can attach, detach, snapshot for backups, and even clone to create new volumes. So, in this lab, you will learn creating EBS volumes from scratch in the AWS console, attaching those volumes to your running EC2 instances, formatting volumes with Linux commands, configuring automated mounting with FS tab, creating snapshots backups stored in S3, restoring data from snapshots in the newer volume. So imagine this, you are managing a production EC2 instance that needs an additional storage. You will need a new EBS volume and make it usable, implement a backup strategy with snapshots, and prove you can recover from data loss. So let's jump in. First task is to create a new EBS. For that, you have to go to your uh, workbench, click on AWS, so till the time it's loading. So let's discuss what is uh, EBS. We are creating a brand new EBS. So what is EBS volume? Till the time we will be joining, it will take time. I will explain it in the part. So let's search instance which is running as lab according to workbench. Select lab. Uh, this is in US West 2A availability zone. So availability zone for this instance is something you will need to remember. So why does this matter? EBS zones are also specifically tied to availability zones. You can't create a volume in US West 2B and attach to an instance which is in US West 2A. They must be in the same availability zone. This is a common gotcha, like common problem, a silly mistake you can say in production that can happen. So let's look at volumes. Go to EBS, go to volumes. There is already an 8 GB volume. That one is root volume for our lab instance for its operating systems. Create volume. According to our lab, we should use GP2 for this lab purposes. Uh, we need only 1 GB. So GP2 SSD uh, is a good balance of when it comes to price and perfect for most of the workload. IO2 It has highly performance database needs consistently low latency. So that is when we use IO2. So I believe when these labs were created, GP3 was not there. That's why it's not written. And cold HHD is infrequent access. So if you need some data, you don't need some data very frequently. You need to just store it. You can use HDD. It has very uh, high latency rate. So we are using GPT. So it's like um, we need 1 GB in production. We are keeping it smaller for learning processes. In production environment, of course, your application will need more data. And then to REST-way is same as EC2 instance. Now let's go to tag, name my volume. Make sure to have this one saved. Create. So tags help with organization in production environments where you might have hundreds of volumes. They are essential for cost allocation. So before we begin, I didn't introduce what's EBC. So let's just have a second and understand actually what is EBC volume. It's like essentially a virtual hard drive that lives on AWS data center. It exists independently from your EC2 instance, which means you can either attach it, detach it, move it around. It's process even if your instance is terminated. So you can snapshot it for backups. You can create new volumes from those snapshots itself. So now we know what is EBS. Let's go. Let's attach this to our instance. Okay, my select my volume action. This is available. Oh, this is being created. To attach volume. Now our instance and device name need to give STB. Okay, what's this device name about? So in Linux, devices are representative as file in the dev directory. Like primary volume is dev/sda or dev/xvda. So our new volume will be dev/sgb. We will use this identifier when we will be formatting it and mounting it to our EC2 instance. So we have attached this within seconds. It's available for our EC2. The most important thing to remember is just because the volume is attached doesn't mean we can use it yet. It's like a plugin. A new hard drive is plugged into your computer. The hard drive is connected, but you still need to format it and mount it before you can start storing files into it. That's exactly what we are going to do next. So let's go to EC2 instance and connect it. So let's check if it's so we are seeing uh, all the mounted drives, and this is 1 GB. This is the primary uh, root volume that's mounted onto our system, and various other temporary mounted file systems are also there. And you can see our okay, you can't see this. Let's see if that is attached correctly. Okay, this is attached. Did we forget a step? No, I don't think so. Let's look into confirming volumes in use. Volume in use. AWS story. Everything works fine. So you can see that our drive should not be present. Okay, my mistake. We need to make that drive. So sudo mkfs minus t ext3 def sgp. So mk is make, fs is file system. So make file system command. Minus t extend3 is a file system type. Extend3 is which is used by Linux by default. It's reliable and journaling file system. And the third is our device name, which we specified while attaching. So you can also use ext4, which is more modern, or fxs, which is more better for the larger files. So dependent on your needs, you can use the file options. For us, for this lab, ext3 is best used. So this command writes the necessary data structure to the volume, so Linux know how to organize file inside it and directories on it. So let's create a mount point. What is a mount point? So what mount point is just a directory where we will be accessing this device volume. So let's make a directory sudo mkdir dir mnt. We will call it as data store because that's given in the lab, not I will be doing anything. So in Linux, /mnt directory is traditionally used for temporary mounting file systems. So that's perfect for our use case. Okay, let's see the next. So when we restart it, we need to mount it again. That will be a headache for it. So we will be making a persistent mount. So every time we restart it, it should mount again directly. So let's mount there STB MNT data store anything data store. We need to specify again the type I was just checking. I don't know this, but data store needs like file system, so we are giving it again defaults, no more time, one space two. Sudo. So we are writing in a file t minus a etc fs tab. Oh, my mistake. S tab. Something is wrong with it. Let's debug it. Echo. Let's check what's wrong. Okay, mount keyword should be not there. Okay, my mistake. First, we will be mounting it. That's done. This is mounted for now, but it's not persistent. So we will make it persistent by copying this, copy this, paste. We have written it in the FS tab. So in the first command, as I told you, we are mounting our volume SSGP to the data store. Now we can start using it, but FSTB is a file system, table file system, that is config file that tells Linux which files to automatically mount at boot. So we are writing in that file. Without this, the mount will be lost when the instance is rebooted. As we said, that this is done for persistence. Default and no time means mount. These are mount options. To know a time improves performance by not updating access timestamps. And 1 and 2 is dump and pass settings for backup and file checks. Like so these are like options that are set. So default is like read and write, and no time is it reduces the time to write normal behavior. If we are giving 1, so that means dump enable, which is rarely used, but we are using for our lab. So it controls the dump backup utility. So I'm just saying that dump the backup utility Generally, it's zero, don't dump. And last two is correct for non-root file systems like home. So zero is for FSCK and one is for first check and second two is for check after root file. So in which order it should check after booting, like after the file system, after your root directory is booted, then only this is the last priority to check. So and be mounted. So this as well too. Now we should check if our file is written correctly. So I will just do fs tab in the table to see. Yes, it has some kind of data which is fx sometime. Okay, maybe it doesn't have the data. Mode from instead of I will just paste it. Yeah, now it's written. HTML data store section 3 defaults no time 1 2 Suzuki ETL. So yeah, I had done a spelling error while trying to do echo. That's why it was not creating it. So it's perfect. Let's verify the mounting again by doing df minus h. So this is mounted. It shows as this name NVMe in 1 and 1 rather than SGB because AWS uses NVMe for EBS volumes on modern instance type. So mapping still works, but the naming convention is changed. So let's create a test file to prove that everything is working. Sudo sh minus c echo some text has been written MLT data store file 1. So we are creating a bash file to create a text file. Okay, y minus c sudo. So we need sudo for writing to the directory owned by the root, but we also need to redirect the output. So it's make sure that entire command runs with higher privileges. Let's read the data. It's stored correctly or not. It has been written. Perfect. Our EBS is fully functional. We have taken it from raw unformatted storage all the way to mounted usable file system with data on it. That's exactly you will be doing in the production also. when we will be adding storage to our EC2 instances. Let's move to task 5 now. So we need to create a snapshot. Let's move to AWS console again. Go to EC2 volumes. So what is a snapshot before we begin creating? Think of it as an insurance for your data. Point in time backup storage in S3 presence. Like you have a file, or you have a DB file. It has 5 entries. You are creating a backup. So in future, in after sometimes it gets hacked or it gets deleted by someone, you have a point to roll back. So it's like creating rollback opportunities, checkpoints. So snapshots are like that, insurance points. Incremental first snapshot copy has all the data. Subsequently, snapshot only has change blocks. Like first will if when we create first snapshot, it has 5 entries, and then we created when second snapshot, it has 7 entries. So only two new entries in the new snapshot. Uh, create can create new volumes from the existing snapshot. Like I have full on AW website HTTP and images that I want to use in two servers. So I can I have attached the volume and stored the assets over there. I will create a snapshot of this and use it in the other instance. Where like if zone A and zone B both are web server, one is for failover. So in zone B, I will be using the snapshot from snapshot created volume. Okay. And it can be shared across AWS accounts, copy across AWS regions. So if US West to A has a volume snapshot, I can create a volume in US West to B for a server that's running on US West to B. So let's go my volume, latest. So snapshots. Okay, create a snapshot. According to that, you just need to give a tag name, my snapshot. Let's review it. This is capital. So it's not case sensitive or something, but it's given labs requirement. That's why we are doing that. So let's go to snapshots. This is our snapshot. Typically, tags helps to organize, especially when you have dozens or hundreds of snapshots in production. Tags will help you out. So, is it pending or done? Let's check the status. It's pending. Let's wait for it. So, this is completed. So, one of the important line is snapshots are incremental. So snapshot only copy used storage blocks. Empty blocks don't take up any space in snapshot. So this is why our 1 GB volume creates such a small snapshot. We barely used any space, so that's why it's 53 MIB MB. So it's MIB because it's virtual. Okay, and so the MIB and MB have some difference. How much it's there? Let's see. MB versus MIB. So this is used for digital, and the conversion is a bit different. So one case 1000 K is in this, and in this we have 1024 bytes. Okay, so in the virtual one, you have 1024 bytes, 1024 KB is MB instead of 1000. So, how snapshots are stored? They go to S3 buckets, but not, they go to Amazon S3, but not into buckets. You can see uh, AWS manages the storage automatically behind the scenes. So snapshots are stored during across multiple devices for durability and incremental after first snapshot only change blocks are used, and it's more cost effective for long time retention. So let's simulate a data loss. Let's delete our file ourselves and get it back from snapshot. I know this is not a real life case, but we need to simulate for the lab. Sudo rm mnt data store file.txt. Okay, just happen just to check mnt data store. Just lost and found. We don't have the file. It's been, oh no, we lost an important file which has a one sentence. Let's do all the backup steps for this. Now, this is perfect scenario. File is gone, accidentally deleted by me, a user, or it could have been a data corruption, a ransom attack, or an application bug, because of which the file got deleted. So let's again revive this file from our snapshot. So again, we need to go to our snapshot and create volume from the snapshot. So most of the settings are already done by it. I can change it if I want, but it's the basic same copy of my volume. Name is not there. Okay. Uh, so why this was a very powerful thing because you can restore a very large volume if you need more space. You can change the volume type to like if you had GP3, but now you're like, I want IO3 for database and the data is in this volume. What should I do? I can create a snapshot where all the data is stored, and in the new volume, I can change the processor. You can restore it to different availability zones as we have discussed. Okay, we can give a tag to this. Tags, manage tags, add a tag. This is a requirement in the lab. Name is to volume. Okay, name. I'm so sorry. It was my mistake. My mistake is to volume and it needs same name, so I'm just copy paste. It's 2 a.m. Back up. I'm so sorry for the disturbance. Okay. Um, I don't want it to see the time. It just was a mistake. Let's attach this volume to our EC2 instance. And give a new name, SGC. And we are done with attaching the volume. We have to wait till it's in use. So let's see, status check is insufficient. Let's modify this to GP2. For all our purposes, of course. Let's wait till it's done. Okay, after a wait, it's in use. Now we need to attach this data again, same way that we did for first one. Let's use that command only. Create data store to let's mount data store to STC. So you see one thing is being changed. I didn't write the extension txt because the volume file system is already created. We are just restoring it. So we don't need to create, it's already ext3. You can even, if you want, do df minus h to make sure this is present. Let's do ls mnd data stores store to file.txt. It's present. So let's read it. Is it the same one line content that we lost? Yes, this is the same line. So we have successfully restored our data from Snapshot. Why is this? What's this demonstration? Like, why this demonstration is useful. In a real life disaster recovery scenario, this is exactly how you will recover from EBS deletion. Like if your EC2 some kind of a problem happened and you lost your EBS volume or you lost your instance itself and you had a snapshot, so you can attach it to new web server and use that data. So for accidental deletion, like we have discussed, failed updates, sometimes update fails and it can't be rolled back and file system hangs. So we before update we can have create a snapshot, and then if it's failed we can remove the volume and attach new volume created from the snapshot. You can even compare the files, like what was the original volume and what is the restored volume file. So the complete workflow was create a volume and store data on it, take a snapshot backup, simulate data loss, restore from snapshot, verify if it's completed. So what are some of the best practices? Don't create snapshots manually. Automate it. We have a lab for this, creating automated snapshots according to policies like daily, weekly, or monthly, and have retention values like only keep 7 and delete all the previous snapshot. Keep recent to delete all the snapshots. Tagging snapshot automatically for is very powerful tool to manage when it's in the production, when we have hundreds of snapshots created. Deleting old snapshot can control the cost. So enable encryption for your EBS. Why to encrypt? All the data at rest is encrypted. All data in IO is encrypted. All snapshots are automatically encrypted. So performance impact is negligible on the instance type. So I will say set a account level to encrypt all volumes automatically. This prevents an accidental creation of unencrypted accounts. Use AWS KMS for key management, centralized key rotation, granular access level, audit trails. Choose the right volume. So like GP3 is the default. So it's best price performance ratio with the and provision for IOPS input output per second, and throughput is independently set unlike GP2, and it's 20% cheaper than GP2. So GP2 database IO2 database requires a lot of consistency, low latency performances, and is mission critical applications. So IO2 is 99.999 durable in SLA, and throughput optimizer SGL1, that's used for big data. SC1, that's cold HHD. I told you it's infrequently accessed and it's mostly used for archiving and backup. Monitor your EBS performances on CloudWatch, like volume read and write bytes, volume queue length, burst balance, volume idle time. Set up alarms for this so you can detect anomalies, understand the availability zone limitations. As we said, we can use a US West 2A volume in US West 2B instance. Cost optimized, so delete volume when unused. Have a automated system. The volume is not used at all for this many days. Delete it. delete your old snapshot also with the automation. Use right size volume, define it. You can always grow it back, scale it up if it's less, and use lifecycle policies for archiving older snapshot at lower cost. So, all right, let's wrap it up. We have covered a lot in this lab about EBS. So, in real life, uh, this isn't just a lab exercise. You can use this in your project. From the AWS Restart Lab, you can create a bigger project combining all the labs into one use case where you can manage the block storage for EC2. So, if you like this video, if it was helpful for you, hit the like button, subscribe for more AWS videos. Comment below with your question and topics you want to cover. I thank you so much for watching. Remember, the cloud skills you have built today are going to pay dividendly throughout your entire career. Keep learning, keep building, and I will see you in the next video.